Welcome to a lesson with Dr. Powell. How can we tell algebraically that a function has an even symmetry or an odd symmetry? Well, let's look at an example. Suppose we have f of x is equal to x squared plus the absolute value of x, maybe plus 1. All right, so let's look at this one. Now, remember, both of these types of symmetries deal with reflections or studying reflections, either a reflection about this axis or a reflection about this axis. Since both of them deal with a reflection about the y-axis, which means that the x values reverse in their sign, so we're multiplying by -1 to all the x values, that's the one we start with. So if we look at this, we simply replace all of the x spots, all the places where we see an x, with -x. That's because we're like multiplying -1 to all the x values. So if you multiply -1 to all the x values, then your equation would look like this. So then the question is, when we reflect, so multiply by -1 to all the x values, so this is the equation of the reflected graph, then do we end up getting the exact same function? Does it look the same? Because if it looks the same, then it's even. So let's see if it does. Let's do it algebraically. So you see this square, what does a square do to a negative? In fact, if you want, you can even write it like this, -1 times x, and then you're squaring. And then exponents always distribute over what they represent duplication or repetition of, which is multiplication, namely, or division, if you will. So exponents distribute over multiplication, division, but not over addition or anything else. So that means you can distribute, means you can take it to both parts. So this becomes -1 squared times x squared. Now this right here is just +1. So it looks like this first part is just x squared. Now what about this? Now absolute value ignores negatives. So we may as well just write this as this +1. Notice that the resulting equation that we get looks the exact same as the original one. It's the same algebraically, which means graphically it will be the same, since a graph is just a picture of the solutions of an equation. So therefore, this has even symmetry, because a reflection this way preserves the graph. Thanks for watching.